warm welcome to Day 4 of the AICT Auto-sponsored 6 days faculty development program on application of data science, enhancing teaching and research, scheduled from 28th July to 2nd August 2025 and organized by Department of Computer Application, BC Roy Academy of Professional Courses. We are delighted to have you all with us as we continue this enriching journey into the world of data science. We look forward to another insightful and engaging day of learning, collaboration and exploration. Let us now felicitate our esteemed speaker, Mr. Monodeep Saha, Consultant, Tata Consultancy Service. To do the honor, I would like to invite Dr. Rajiv Roy, Principal of BC Roy Academy of Professional Courses, to felicitate our esteemed speaker with a token of our appreciation and heartfelt gratitude. Sir, please. Thank you, sir. We would like to introduce our resource person, Mr. Monodeep Saha. He is a part of Tata Consultancy Service Analytics and Insights Group. It is a data analytics and consulting group. Mr. Saha has specialization in risk regulatory practice as a consultant delivery manager in the same space, managing a multi-geographical business ranking in few BBUSD. He consults banks across globe on new open technology in credit risk pitfalls, successful implementation, use of artificial intelligence and machine learning techniques. He has over 17 years of experience in analytics consulting in various domains. But last 10 years, he has been developing and managing credit risk and fraud risk model development across banks with his own specialization in wholesale model development. Pre-TCS, he had been with a credit bureau and a few large analytics consulting firms. He is himself a author of one of the books published in Springer and 14 books of the sustainable technology using open data and machine learning application as a co-author. He is one of the second workpiece is working in progress. He has a master's in physics with specialization in scientific computing and advanced mathematics from Indian Institute of Technology, Madras. He is an avid runner and participant in marathon when he was not professionally involved or not involved in literary work. In this session, he shall learn about data science in banks and credit risk modeling. I now hand over the session to Mr. Monodeep Saha. Sir, please.
Providing the opportunity to work here. And this is my first time experience with having this kind of a session. So if there are any kind of lags or any kind of statement, please that I am not able to communicate the message to the group, just stop me there and there and ask me a question. I think we have plenty of time. And I deliberately kept the number of slides low so that we can have a more interactive session and I can, and I'm very comfortable in Hindi and Bengali as well. So feel free to choose your language wherever you feel that you want to stop me, hold me there, and we can continue from this. So, so this this field, right? So the question, so I'm going to cover credit risk modeling used in banks. So what is credit risk, right? So it's a division of data science. And my objective is not to teach today directly about like, okay, this is credit risk, okay, this is the maths used in there. I will touch upon everything because practically it's an interdisciplinary field. I have 17 years, but I'm still a student. I'm learning new day. Every day the technology is changing. There are new challenges coming in. Every day new stuff is happening, and every new problem gives that ability to learn. And I would say any given bank or any given industry, I think there are always three divisions. One is the people, the process, and the technology. So we keep learning about technology. People are obviously the biggest piece. The way you communicate with your peers, the way you communicate with your stakeholders, the way you communicate with your basically regulators, the way you communicate with each and everyone. So, and the sequencing of the slides would be pretty different probably what I am going to speak. So this is basically the anchoring material which will take you like this is the sequence, and later on if you read you will get the sense of it. But I will start with something which is kind of going to probably set up the background, and I'm personally from applied physics background, so mathematics and physics have been my first passion. Programming is something which drives me each and every day, so I will start from there, but in a more fluid manner. I mean, not exactly picking up the pen and paper and starting like programming. So, and let me come down to the board, right? So, pardon my handwriting, it's very bad. So, we will go reach here, but we will start from there. So, and this is basically the backbone of it, I mean, in terms of the mathematical language. And I'm not just speaking of what is today, I'm teaching what is going to come in next 5 to 10 years. And and since everyone, a lot of the bigger group here is from mathematics and engineering background, some were probably from pure sciences background. So this might be something where if you might have read about it, what is objective reality, right? So objective reality is basically a fact that I'm seeing today. So for example, me standing here right now is an objective reality. It is the fact which is happening. But every one of us has a different viewpoint of looking at it, right? So probably ma'am is looking from a different viewpoint and sir is looking from a different viewpoint. I myself might have a different viewpoint as well. So learning it by using different apparatuses will have different type of results. But then the final reality does not change at all, right? So that is my objective reality. So basically what happens is, let's assume there is a someone with, let's say, L1 and he is observing using apparatus O1, and someone with L2 and he is using apparatus O2. But here, this is the objective reality. So this is not going to change. But how we are going to look at it is going to change, and what it finally leads to that. So when L2 is reading into that, this is one by different means of reading into it. L1 would have to, so now let's say L2 reads about it and L1 has to know about it. How do they do it? So basically there is a transformation process that happens that they have to communicate back, and this is exactly the way, we would have a lot of people and married people would be there, right? It's basically, if you have a fact that is happening in your married life, now husband and wife, they have to communicate, so they could see, so wife is looking at from a different angle, husband is looking at the same objective reality from a different angle. But then they would reach to the same consensus point, and that is the transformation in the coordinate system. And that is exactly happening everywhere. This is something now, where does it lead to eventually? This is something which is the backbone of tensor mathematics. So what do we do in tensors? Tensors is nothing but basically a way of building that mathematics. So what do we actually read in there? And people would have, if they are using their books, Spiegel for engineering mathematics, the first and the second chapter are about scalars, if I'm not wrong. And then we have vectors. I think that's where most of it stops. So what is scalar? It's rank 0 tensor. And this is rank 1 tensor. And then we can create, so the more advanced levels are dyads and triads and pentads, quadrats, pentads, like this. So they are higher ranking tensors. What is tensor? That it is the order to the rank. So I think that is what how the tensors are divided, and you can devise your own mathematics. It is not, so this is the backbone of building the mathematics. This is not even where the mathematics automatically comes. So the idea is, let's say, and why did I touch tensor here? Is that when we are solving a particular bank's credit risk problem, it eventually becomes a multi-dimensional problem. So we have to create the dimensionality space. So today we are doing or dealing it in a very different manner. But tomorrow we will have to be flexible, and basically this entire thing eventually will be used in the future, where we might be using deep learning for all those generative AI. And how do we use generative AI? It's not just, okay, I use the ChatGPT and it's done. It's not the way. Banks do it from first principles. Or because you have IP rights related things, you have domain things and all of this. So your mathematics have to be very, very robust and strong. So this is the backdrop of it. So all of this, the deep learning models which are used, basically, they used tensor mathematics as a background. So the key aspect is this: your objective will never change. It's a physical fact. It is not going to change. How you are going to reach to that might, you have different ways. You can come from Asansol to Durgapur BCI Engineering College in multiple ways, right? You can use a car, you can use a train, you can use, but eventually you will reach there. So that is the central point of fact. So that's not never going to change. So I think that is the first fundamental piece of it where I wanted to touch upon. Obviously not to confuse everyone, but if you are confused, that is good. You will read a bit more. You will read a bit more of YouTube videos, what is deep learning, what is tensor. Initially they might look very disjoint. I can feel a bit louder. I don't need mic.
বন্ধ করে দাও, ছেড়ে দাও। ডিপাঞ্জন
মাইকটা বন্ধ করে দেন নাকি?
ফালতু
না না লাগবে না আমার
এটা একটু করে ঠিক আছে, একটু গেনের জন্য তার জন্য
So I think so that is the beginning point of it. Now we will switch because gears from here. So this is something I just thought that this is a good morning beginning joke basically. Dilbert, I think everyone's favorite product. So what is it saying? So and this is what happens in a credit risk regulatory space. So now, so this is what exactly happens in the regulatory space. That so this guy here. So this guy here is probably me in my day-to-day office. So who is like questioning the team that hey, you see everything needs to be documented, even the backhand of the napkin where you are writing an equation that is the same model. So document everything. So and then these are like the junior analysts and like around 15 years back I was here probably. That so one of them is saying that even the one here marketing decided that prices deposits drop rate 10%, blah blah blah, and that feels right. So he says that okay, put the next 200 pages of Excel sheet into and create a tool, and that could be a model now. So then this guy is saying that okay, we now have created a generative AI, which is the latest joke actually, the Gen AI joke which is coming into the regulatory space, because regulators are very skeptical. Today, the current state of it, exactly right where I am standing. So, so Reserve Bank is slightly behind, but then actually there are two major bodies in the globe which are into the credit risk space from a regulatory standpoint. Regulators, I would say. And actually, Reserve Bank also falls under one of them. So, one body is known as Basel. It's actually based out of a city in Europe. Basel, there is a city. So, they first created the norms of it. Now, there are I think fourth generation norms that have come. And why did it came? The massive event of 2008, the great financial recession, what we saw, say, right? And there are some other events preceding to that where the financial world collapsed. We have the event of, I think it was Lehman Brothers or Lehman Brothers, sorry. So Lehman fall, and then I think Basel I really got implemented in full scale. So the second body is also known as IFRS 9 actually. So IFRS is more like the nicer side basically. They say to the bank, you can do it this way, I'm flexible, but if you do not do, you have a chance that I might penalize you as well. Basel is more like that stringent white rule set, if you do it, I am going to penalize it. You have to do it in this way. So all of North American banks and Australian banks. Australia has a separate, Australia is actually under Basel. Australia has another body called APRA. So APRA is basically again covered under Basel. IFRS is more into India, Middle East, a lot of Europe. So, but they eventually, what do? There's something called loss provisioning. I might use this part of the book. There is something called loss provisioning models, and they measure expected credit loss, and this is the important one, right? So wherever the word expectation comes the probability comes alongside. So it's not actually the credit loss, it is my expected credit loss, what I'm going to go into that, and then what I will do is basically decrypt it into how the loss models are going to be created. So that's something we will cover in the subsequent chapter. I will just setting up the background. So this is how basically this kind of works. But then this is something which I wanted to, this is all global stuff, right? Okay, it is happening here. How did it is even relevant to us? Right? So, global is fine, but how does it impact locally? So, this is one of the events actually, it really happened. This is covered by the World Bank in their thesis paper. So, I will tell you the story. I'm not going to go like exactly all of it. You can read all of the content. I'm just going to summarize it into the next 5-10 minutes and tell you the story, which is the interesting part. What happened actually there? So, let's go back to the 2008 year when the global financial crisis happened. So, Atal implemented everything, and okay, let's go with that. But then, in India, and this is around 2010-11 time, microfinance industry came into existence. Microfinancing is more like farmers, Krishi Vikas Yojana and all of that stuff. So, Krishi Vikas came into existence. Women empowerment was part of it as well. And then people were given a lot of women were empowered. They were given a lot of what you can say funds and things to run their shops. But even well-organized programs can run into problem if they are not well regulated and if they do not have the right kind of backbone behind it. And I think somewhere this event kind of happened there. So what happened exactly is that Andhra Pradesh, Telangana, the then government, they basically decided that let's push the banks to give SME loans to women to probably so the interesting or the important part is that, and we will cover further the business part of it, that why it went wrong and how this can be applied across any of the businesses. So we will look into that layer part. This is just probably a beginning case study. So the women folks, they were kind of under poverty line, and just below the poverty line, and they have difficult time in terms of meeting the means and the. So what happens? They are getting funds, but eventually what is happening that their ability to return back, and I'm choosing the words carefully because I'm going to stitch it back to how this entire story goes and stitches back here. So their ability to pay back the amount of debt they are taking or the loan they are taking, and their ability to pay it back was somewhere not there. Because so what did they choose? So they took loan from one bank. They tried to ramp up their shop, but then things are not working. They took a loan from the second bank, and then from the third, and then from the fourth, and then from the fifth. And they're like taking the loan from one, repaying the other one. So credit is revolving. So risk is revolving continuously there, and it's a nine-pin situation. You remove one from the stack, and the entire system collapses. So what happened exactly? That happened there. So every situation which is goody-goody, one point in time there is a tightening event happens and the system collapses. And exactly that happened. The system got suddenly tightened in 2012, 2013 and subsequent years of it. And banks run into NPL problem. They have, okay, now bringing more stringency, try to figure out who are not. So then loan recovery sharks and loan recovery agents start coming into picture. Banks have got them. So they reached out to women, they tried different, and not only women, some of the poor folks as well, so they try to extract the money, and they do not have the means to provide it. They were like doing so, and where the problem was there, before giving the loans, you have to also look into what is the credit quality they bring into the table. If someone has the ability to pay only, so it's like, I have a very good friend. He asks a loan of rupees 100 from me, and he has ability to pay back only 5 rupees. Now I have to see how long he will take to return it, whether he has the willingness to return it back and the ability to pay it back. So both the sides of the equation are equally important. So if either of the two pieces are missing, there is a problem of the repayment, and the NPLs or the non-performing loans will come in the picture. And that is exactly happened in this particular situation. What eventually happened is that from that segment of people, there were suicides started to happen because they were pushed to the corner. They had no means, and in the political system also started to come into action. A lot of chaos happened after that. This event actually came into not only in Indian news but globally. This become a big lesson for the banks that if you are doing something, even the intention is good, you need to be very, very stringent, and it needs to be regulated. You are giving loan to someone, good, but then someday that loan has to be paid back as well. So credit risk forms the backbone of that. That is why we are doing this entire business of credit risk modeling. We are modeling that particular. So I am trying to bring in. I'm going to rub a piece of it, probably the tensors part. So credit risk is, so this is basically an amalgamation of multiple fields. Finance plus accounting comes into it, mathematics comes into it, computer science comes into it, machine learning comes into it, data science comes into it. So the question is now again that, okay, so many things are coming, it's like cooking a biryani, right? So now when you cook a biryani, the challenge is not the masala, the important piece is basically how you cook it, right? So the art and the science of it. So the science is coming from here, but then the analyst has to also think through that what is going to be the implication if I do so and so things, or even the management also becomes, and someone has to take the accountability, and that's why this is one of the only data science fields as of today. And I think banking financial services, that's why they are extremely robust. They have a division called model development, and actually I belong from this department. In this department, and there is a parallel department of scrutiny which is called model risk management or independent model validation. So whatever I do before passing on to regulators, first has to be internally QA'd not only on the codes but on the methodology, data, technology, everything, whether it's working or not. And even if it's working, the implications and the insights what I am bringing to the table and my department is bringing, whether it makes sense or not. So that goes to like a first check here. Then it goes to this MRMG, it's called in short, Model Risk Management Group. So whatever risks there are present, even the systemic or the non-systemic risks into the models which are developed, they get passed through here. And models are generally broken down into tiers, like tier 1 models are heavily where direct inflow or the balance sheet angle comes into picture. And tier 2 models are there. Tier 3 and tier 4 are generally marketing models. Tier 2 for fraud come under tier 2. Tier 1s are risk models, core risk models. Now, this, I'm sorry, the board looks very dirty. I just hear this. But the idea is basically this differentiation. let's again further go back from that story which we started, right? Let's try to understand that loan thing. We discussed that we are trying to now again touch upon that. What exactly, and these are the basic definitions. If once we understand these, we have a chance to probably understand the things better. So loan is probably the first term, and I think we all know it. It's just mostly the Wikipedia definition that's what I said. But the idea is basically that if I'm lending you money on the good faith, and then I am trying to figure out the assurance that that money will be paid back, or it is by any given entity, whosoever is the lender. So, and the main piece in the entire thing, or any given businesses don't run on money. I think that is something which I learned in school first, but then also in the industry, that there are two things. I mean, why do businesses happen? Businesses happen because there is a instinct of survival. It's basically surviving each and every day. And businesses does not run on money. That is the false thought process. Businesses run on good faith and trust. If there is no trust, no business will happen. But trust is the building block. And this is the missing ingredient. Even when we model it, that is something which is missing, but we are trying to capture it through various features. And I think that is where the principles of generative AI are slowly coming into picture, because the textual or the contextual data which we are missing into our quantitative data will someday be captured. We are still there, we haven't reached there. Probably next couple of years we will reach there, but apart from the context, what is the sentiment that is coming out, right? That plays a lot of role, and I think there are certain newer startups actually. I think you might have Credit B, Lending Cart is one of the startups. So they are basically building those kind of models, which are, and there is something called Credit Fluid as well. So this is something of a global startup which is into the money lending business, and the idea is basically it's a peer-to-peer lending group. The idea is basically, so for example, there is a guy who says that I want I need 1,000 rupees to buy a bicycle. Now he posts that on a LinkedIn or a Facebook page that I want to do it. He has 100 friends who see his behavior from a day-to-day basis, that this guy is will pay back. Someone writes a comment that, oh, he will pay the 1,000 taka near a favorite PC level. Someone writes that in under quotes in that comment. Someone will say, oh no, he's a nice guy. He will pay back everything. ये जो लेगा ये वापस pay कर देगा. So likewise, I mean, all of, and this can be multilinguistic. Why I use actually Bengali, English, and Hindi, all three dialects here, because this will be all multilinguistic, and that's where the usage of natural language processing and the your BERT and other processes, the GPTs and llamas which are using them in the background, that will also come into that. You speak or you write in any kind of textual, and it can be not only written data, it can be someone just posts a video, voice text as well, that will also be captured into that, and all of it will be combined together to see and figure out whether it's making sense or not, and it will be combined with the existing balance sheet data, numeric data, behavioral data, and all kinds of data sources which we are looking into. So the scope is still unlimited, or I would say there is a massive scope, but the industry is grappling through it. So North America, I have seen that they are leading the charts in terms of data accuracy, and but there are also massive problems. Europe is behind them. Australia is somewhere between. Probably it's just close neck to neck with Europeans. So India is, I think, the data quality piece is slightly behind, but India is, I think, in some areas India is much ahead. For example, the UPI payment structure. This is one of the latest inventions, I would say. Even US does not have this kind of a payment structure, and probably India is going to even go much deeper into it, and that is bringing the peer-to-peer system into effect as well. So India's innovative strength in, for example, this UPI and payment. So in payment businesses, India is in certain things, the scale at which India operates is much higher. But all of these transactions definitely bring the credit risk aspect into the picture. So again, let's go back to here. So this is basically, so what does this additionally bring in there, right? So I'm going to disrupt this piece now. I try to make the better use of the board. Today is 30th. 31st.
31st.
31st. So, I've covered this last piece, right, which says future repayment brings the concept of time value of money. So this is something. So now loan is getting connected with finance. So how do all of these angles get connected to each other? So time value of money is a very, very critical concept. It's basically, and I think everyone is mostly, I believe, is aware about it. Whosoever does a little bit of investment, they know if I'm putting the money today and there is an inflation, there is an interest, how much I'm going to get from it tomorrow. So I think that is the bare minimum concept of it. But then, in the loan business as well, if I am giving someone 100 is, I've just kept the number to be a bit smaller so that it's easier to take care of things from here. But then, the idea is that if I am giving this amount today, and let's say 100 is actually 120, but I'm just keeping it 100 so that it's easier. So let's assume that there is a small kid and he's saying, give me a chocolate of 100 rupees, Papa, and Papa gives him 100 rupees worth chocolate. But then asks that you will work every day on your assignments, homeworks, and equal notional value of that 100 rupees. You will study and give it back, and then it will be also adjusted with time. So today you will study in class 2 and get your results, then tomorrow in class 3, then in 4, and then subsequently in class 10. So this is something of that, the notion is something similar to that. So what is worth today might not be, so if let's say we divide it into 10 and 10, 10, 10, 10, 10, 10, we can say, but this 10 is not equivalent to this 10. There is an interest value and all of those is there, but more simplistically if you want to understand, this 10 is very easy because this is basically at my hand's distance. This is a very remote future. 10 years from now, I don't know what is going to be the state. Right? Even if it might be possible that I might never be able to, or anyone who, they might not be able to recover that 10 or whatever. So, this 10 probably to see that I am able to, and that is why the concept of interest rates come into picture. What is interest rate? Interest rate is nothing. It's not just that, okay, I have to put some this. Interest rate is basically if there is a higher risk propensity that I might not even get that amount back, let me put a particular charge on top of it so that when I recover it is, so it's a weighted average of risk basically. So today is 10 and futures 15 probably might be the same thing. Or even 18 depending upon how the other factors and inflation, interest rates, spreads, yields, everything define that weighted average proportion. That is the math or instrument to reach there. But the idea is that today's 10 rupees and tomorrow's 10 rupees are not safe. If I say put them into the same bracket, it's like for the same crime I'm punishing someone more or punishing someone less. Here it has to be definitely on the higher scale. Because, and this is the propensity, because 15 years or 20 years back, yesterday's 100 rupees is not equivalent to today's 100 and future's 100 rupees will not be equivalent to today's 100. So it's basically that adjustment factor that is coming into picture. So when we give loan, that adjustment factor has to be taken into account and that is basically the concept of time value of money. So all of these concepts, small concepts keep entering inside the loan calculations and everything. Now, when I'm giving loan, what do I look into? So, generally, there would be, this is called actually 5C characterization. I've probably not kept 5 C's here, but the idea is basically, and which I was talking about earlier in that case study, that there are this segment of women folks in Andhra who were taking loans but they were not able to repay it back and there were challenges. So the first thing, DTI, LTV, DSCR, what are these terms? Right? Let's decrypt them up. So DTI is debt to income ratio. So how does it look like? Debt is on the numerator and income is on the denominator. And let's spend some time on each of these because these are the backbone of the ratios, basically what is today and how things are measured today across globe. Not only just probably not only Yes Bank, HDFC, ICICI, Axis Bank, but everywhere. Be it the Citibank in US or be it Wells Fargo in US or some bank in Australia or in Europe. So everyone measures this in this format. Probably debt to income is basically measured at a personal loan level. When looked into the wholesale business, it becomes loan to value or DSCR. So we will go into each one of these. So debt to income ratio is debt by income. So what does it mean? How much I am earning versus how much loan I am taking. Right? So if I am taking, let's say, loan of 100 rupees and my income is 10 rupees. So my loan is practically 10 times what I am able to pay back. So it's a burden on the person, it's burden the bank knows beforehand that 10 times they have to. So the bank is taking a 10 times of the risk there. Now what is the amount of capital they are getting? So let's say this is the right hand of the equation, RHS, that 10 times is my risk. So they now have to look into something like how do I mitigate it, the bank or anyone. So if you, even the yesterday's, what we had a very bad word, Soothkhor, right? So even that Soothkhor used to exactly evaluate in the same form, not in the mathematics now we have failed, but they have the same thing that if I am giving this much and this is the loan paying capability, so what is there for me in case the person says, oh I am bankrupt, I have nothing. So then they have collaterals. Collateral is, for example, if I want to get this 100, my income is only 10, but I have some properties, so and so other things. How do I compensate the LHS and RHS? Once the balance comes out, I think that is the point when you try to find out the sweet spot. Now again, there are a lot of assets. For example, if you buy a car, car is not an asset. It's a debt. It's a depreciating value. Because the cars manufacturing and all of these things are depreciating, wear and tear is happening. You buy a car with 10 lakhs, you never get to go on a sell it with 15 lakhs. You are always going to sell it for 5 lakhs, all less, all less. Because it's a definite, and there is a specific way of calculating a residual value of RP, something which is calculated. Now, but if you buy a land, and how does this valuation happen? This is basically a function of demand and supply. It's a principle which comes from economics, macroeconomics, which is, so there is a demand curve, there is a supply curve, and wherever that intersection happens, that is the price points. And multiple such demand and supply curves keep on hitting, and then when you join them, that is the price estimation curve. Right? So, am I going too fast? Sorry, I might be flickering between lot of concepts. So, wherever you feel that, okay, we want to stop you and want to just capture something back where we missed, I will again stop and go back, because these are interdisciplinary concepts where finance, economics, mathematics, they are all combined with each other. No field can happen in one, because at the end we are solving a problem which is at a business scale. So everything has to be accounted, and obviously even for students, I think they will start, and even I will be honest with this, I started with mathematics. That's what I knew when I went into industry. I knew nothing about anything else. Slowly and steadily, and I would not be dishonest, I broke more models than I built in my entire career. So I have and I have faced the consequences as well, but that is the part of the learning. You have to make mistakes. You make mistakes, then you move forward. So never repeat the same mistake twice, but then keep making mistakes. I think that is the way it has to be looked at, and that's how you learn. You basically, so for me, I have initially I did never understood macroeconomics principles because I was never from this field. But then when I made mistakes that okay, this is something which I did, I went back and bought those textbooks, basically what some of my colleagues from the economics department were doing. I wrote those books, read through them, tried to understand, put them, contextualize them, then again put them back into my work. And likewise, so you make mistakes, you go back to the drawing board, you unscramble everything, you start from scratch again, then again start, and this is a process, and you should not get devastated that, hey, this is taking too much time. This is a lifetime work. This is not just one day, okay, I will come and become a modeler. It has to be gradually, there is a graduation process as well. And that's how it happens. So just learn and dedicate yourself to the profession. It's just like any profession. So now, going back here, right? So, car is a depreciating asset. A house probably is a mix of depreciating and appreciating assets. So land, because of the demand supply nature, because the population is ever increasing, the land keeps on appreciating in price, but the house needs maintenance. So it's a depreciating. Now then we have to look at the trade-off. If the land piece is bigger on a higher side of appreciation, then the cost of depreciation versus the profit of the appreciation. So finally you calculate the value of collateral from there. So that's why I went into that. So all of these things are looked separately. They are probably individual departments as well, sometimes analyzing these aspects. Just give me a second.
Sir, can we have tea now, please?
Yeah, absolutely, sure. We can. I know it's pretty heavy. It's going on, so we can take a break for 5 minutes. Should we start or wait for this? Okay, sure. So I think we were, let me just run off this. I think all of it is now clear. But I'm not much of this one. And now I think we will be slightly fast tracking. So I was trying to set up the context in the first half of this, and I thought that now that all of our engines are full, we can start in full throttle. Now we will go into the deeper mathematics and the programming piece of it. I have some programs that will use the machine learning setting, and I will produce them as well. We'll cover this piece and the next slide probably next 10 minutes or so, and then we will fast track. And then we will again jump back into that the tensor piece. So what I will show in the programming piece is that how I will show first the traditional mathematics which is used today, and how tensor can be used to build that same mathematics, and do particular separate process. This is basically one of the competitions right now going on, I think on Kaggle or something. So there is a basically particular entity who is interested in identifying how many animals they have in their zoo, and our poachers are killing those, so they are segmenting and identifying the biomarkers. So, and this is happening through they have put up like collars on each of these animals, and that is capturing image data, and from image data they are building. So even credit risk can be done in that manner. So once I cover that programming piece, I will explain like how in a wholesale kind of a setup, wholesale business or a commercial real estate kind of a setup, how credit risk can be used using image data. Right now it's more textual or quantitative. So I think so these are the backbones of the pillars, and we talked about the case study of poorer segment, right? That how ability to pay back governance, collateral, and I think credit quality is something one of my colleagues and peers just brought my attention to that. So credit quality is I think the fourth piece of it. So the fifth piece of it. So this is how analyzer, this is how underwriters actually in the bank analyze it. So they have details, more detailed Excels and documentation around that. So this is the fundamental principle, the equation of bankruptcy. I've just tried to put it in a very simplistic manner. It's one of my subsequent work, which I mentioned, like one of the other books is work in progress. So this is from there as a script, and the source of it, right? Also, it's not like me. I have written it. I have just tried to summarize it, and there's something in the industry called Altman's Z-score. It basically tries to understand how does the bankruptcy equation looks like. So bankruptcy is a function of liquidity, profitability, productivity, leverage, and activity. So these 5 things, when combined together, can measure if someone is going to go bankrupt or not. In simpler words, that becomes, so if you pose the question like that, how likely, or when the word likely comes, that means what is the probability that your business, or anyone's business in this case, will not go bankrupt. It will be depending upon, first, how much cash you have available. So that is your liquidity, the first point. How much cash you have available in your for the times of contingency. Profitability is how experienced you are in your business. That means your capability to run the business at a, so you would have seen various seasons, tough times, easy times, and all of that. So that gives your, so profitability comes from that angle. Productivity is converted into how much can you get with what you have. So this means that whatever you have, resources, what is the maximization capability you have. Leverage is how resilient you are in case of bankruptcy. So in case you hit the road and you go to a point where you have nothing left, then how can you come back? So a lot of times it's like even with the kids, right? They are running, they fall down a lot of times. Can they again stand up and run back? So that is even true for businesses as well as even for individual retail consumers. And how well can you deal with competition? So you have a lot of competitors. How can you be able to deal? So, and this further resonates into cautious experience, resourcefulness, resilient, and persevering. So this is how. So why I presented this. When we will be building a machine learning model, these are the features. This is how the features backbone is built. And suppose I have two fields which are coming in from cautiousness. Like I will just take an example, and this is something which people can easily relate to. And I will use mathematics this time, not the statistics piece. I will go into the statistics as well. So from a maths point of view, let's say I have one field coming in for cautious, and I'm using some basic tensors as well here, but I'm writing them as a scalar or a vector. So each of these are actually you can say individual vector which is a rank 1 tensor. So these brackets, if you see, this is basically the notation what we will be using for building. So let's assume this is the bankruptcy tensor of rank 1, right? So bankruptcy, so this will be whether bankrupt, non-bankrupt, bankrupt, non-bankrupt, like this. So, and we will say when bankrupt, then 1, when non-bankrupt will 0. So that is how the logic behind it will be also written or looked or translated. For example, we have cautious. So there is some coefficient to it, beta naught, which has been mentioned here. So there will be some coefficient, and cautiousness is one of the features. Plus, we have another feature called experience. Now, assume that whatever, so experience 1, experience 2, experience 3, likewise. It's like you can look into a table. So you have a table and you are kind of looking into it, and there is a cautious that is, so let's, for the time being, let us put experience as E1, E2. I'm not taking the other parts because it eventually boils down to the same idea. So E2, E3, E4, and let's say I have n number of such observations and it becomes En. Similarly, we have C1, C2, C3, and it goes to Cn. That is how it is characterized. Now let's take two concepts, and you might have, so from the properties of vectors, right, the rank 1 tensor, you might have learned about linear dependence and linear independence. There is a word which is used. So linear, what does, can someone give me some idea about what is linear independence and linear dependence? Li and Nd in short. Okay, so I will tell.
So to find the beta 0, beta 1, these coefficients, all having non-zero, their sum is can be 0, then linearly non-dependent between these two will be defined.
Yeah, correct. So the idea is that, and what exactly is happening, there is, if you have read about something called so basically when we establish the linear dependence, so there is something called different things. So quantum mechanics actually has Dirac delta function. But applied mathematics or field theory generally has another function which is also very similar looking. It's called Kronecker delta. Represented by this delta ij. So what does it say is, it says that let's, and I'm right now for ease because it is easier to visualize in this world 3 dimensions. But in real problems, it's a 6-dimensional and 5-dimensional problem. It's not a 3-dimensional problem. So this is how it looks like. So this is I, this is probably J, and this is probably K. X, Y, Z can be written as I, J, K. Now, I and J are perpendicular to each other. That means, and the concept of projection, trigonometry comes into picture, that let's say this is U, this is V. So U dot V dot product is basically U dot UV cos theta. And if theta is 90 degree, then it becomes 1, right? Or in simple terms, they are linearly independent of each other. So basically, if I am trying to measure bankruptcy, I can use beta naught this one, beta 1 this one, and so on and so forth. So I can construct an equation in the first place. If by chance, what happens? Cautiousness and experience, we are trying to still find out at the background. So these two are very similar to each other. Or there is a full dependence, for example. What will happen? Statistics would be tough part, I will go there as well, but mathematics, what will happen? I will create a scalar equation or a matrix basically. C1, C2, C3, and for the sake of convenience, we will keep beta naught, for example, 1 here and 1 here. We will just add these two things. So it will become C1, C2, C3, E1 into E3. But they are same. Now I am trying to identify the value of this matrix. How do I do it? I do it by, so my denominator has a determinant. What happens to the determinant? Cross multiplication like this. This value goes to 0. If they are same. Two columns in the vector or a matrix coming. So below we have a dead here, right? So if the two columns are same, my output would be 0, which is an event of singularity. So my entire model goes for a toss. Nothing is left. So if by chance they are same, I have, so when we are building models, we have to ensure that cautiousness is not connected to experience. So that's why, so what will happen? You will get, let's say, thousands of variables. So you would have different clusters. So this all set of variables can be cautiousness. All of these variables can be a part of experience. So your clustering algorithms come into picture, or basically principal component algorithms.
Feature reduction is
exactly correct. So feature reduction principle comes in. So you have thousands of variables. We're trying to create certain feature reductions, and you're trying to bucket them into these particular groups. That okay, my particular variables are falling under these categories, because by mistake, if the variables will come to, so from a mathematics point of view, this is going to happen. Statistics, there is a concept called VIF. VIF is variable inclusion factor. So what happens is that I'm trying to identify the beta naught. What VIF says is that it's basically 1 over 1 minus Rij square. So basically between my neighboring column value, I'm not able to figure out the right. So what happens eventually is that my confidence limits for my betas becomes very high. I cannot clearly say. So whatever value they are coming, I'm not very sure that whether they are correct or not. So my confidence limits are basically we go to the concepts of mean, mode, and median, right? So mean, mode, and median, what you would say that a particular value, for example, let's say coming to college is 9:30 a.m. Right? Everybody is entering into the college, so we are taking a sample size and every 9:30. Now, people can come 15 minutes earlier, people can come 15 minutes later. So my confidence boundaries become 9:50 and 9:45. But how sure I am that this is 9:50? So I say that okay, with 95% probability, I can say that people are coming at 95. Now this 95 can change to 99 as well. This can change to 91. So here when this Rij becomes impacted, this 99% becomes impacted. So this becomes.
What is that RIJ, sir?
Rij is basically my two neighboring, so dependency, or it's kind of a regressive equation between this and this, two corresponding variables. So when we measure
That is, we are trying to find out the correlation.
exactly, not
correlation between.
correlation, not so there is a difference between correlation and regression.
Regression.
Causality, and so they are not one and the same thing. So something can cause something, but it is not the reason so they can flow in the same direction, but it's not the cause of it. So they are slightly different. So one is called regressive. So A is happening and causing B, that is regression. A is also happening, B is also happening, that is kind of correlation. We are trying to see the pattern between the similarity. So there are different, I think there are different types of correlation calculation equations as well. So, and if you are looking into regression, right? So there is something called R square. So R square and this Rij is different. R square is basically the relationship between your bankruptcy and cautiousness, and Rij is the relation between this and this. So these are regressive relationships, not correlation relationships, but they are trying to measure how C1 and so let's say if I am I'm trying to construct a similar kind of equation and try to find out how connected C1 is C1 is. Right? That goes into each of these RIGs and eventually we calculate the inflation factor. But normally if I am building a regression equation, I am trying to see how this and this are connected, and generally first the univariate models are built before we go into because the moment it's like one person is going from X place to Y place, I can use a bike. There are two persons, I can still use a bike. If there are three people, using bike is difficult, then I have to bring cars. So this means that the more variables you bring in, it has a change into how things are overall being done. So that's why first univariate models are built, then bivariate models are, even before doing bivariate models, trying to figure out the bivariate patterns with the event. So event versus bivariates are looked into. So and yeah. So the ability to when the variance inflation happens, the ability to put out those confidence limit under that I would be able to say that these confidence limits, this event is happening, it's very difficult. So students and professors coming to college at 9:30 p.m. with 9:15 and 9:45 being the confidence limit, I'm not anymore very sure. That's what happens when these two, and in the context of bankruptcy, then that changing happens. So cautiousness and experience both coming together and being similar. The property of linear independence going for a toss, variance inflation coming into picture. And there is another metric actually which is used apart from variance inflation factor. This is called conditional index. So if you refer to conditional index use the matrix property, whereas VIF measures the statistical property, both points to the same thing. So that is objective reality. I am measuring the same thing with different apparatuses, but then I am reaching to the same conclusion. And that's why mathematics and statistics are not divergent. Even computer science uses the same backdrop, reaches to the same point. So if whatever means I use, my end objective is to understand if the bankruptcy is happening or not. That is my main problem. I use data science, machine learning, new technologies like quantum machine learning or whatever. This background never changes. This is the central to it. This theory will never change. Now let me slide across. So I think this is what I was trying to craft out, right? So it's capital, character, condition. Sorry, it was not trade qualities conditions. My bad. I forgot the name. So these are the 5 C's which actually create. So conditions are basically under what conditions this particular that I will or someone will be paying to the bank will hold true, because with changing conditions that can also change. And this is pretty much equivalent to covenants as well, because covenants are the legal documents which hold. And I think I was talking to Sir some times back, and it's basically whenever we sign, we go to the bank, we say, okay, I want a credit card. Or someone says, sir, you are eligible for a credit card, please take this and this is the. So you don't have to do anything. I'm just playing the salesman role. Sir, you don't have to do anything, just paste one picture here and sign here. That's it, you're always done. That is where this information is hiding. And we should never, because the bank has a legal copy of it, and that's why they can send a loan shark or a loan agent later on recovery agent at your place to get the value. So this is where exactly it is being done. This is where it is captured, and a lot of times we don't know the rules and it happens. But bank actually is capturing at that point. So now this is what I was talking earlier. So the business does not run on money. I think that is the misperception a lot of people might have. The secret sauce is always trust. If I trust you, then I do business with you. If I don't trust you, I don't do business with you. And if people don't trust each other, they don't lend, the business would stop moving. So business is about the instinct of surviving every day, and business runs on trust. I think these are the 2 things: cash, collateral, UPI, blockchain, cryptocurrency, all are means of those kind of what you can say. It's a goodwill basically. And that's what I think. And most of the sales people, they are not just behind the money; they are behind earning that goodwill. That is the key factor. And that is what actually. So the events like 2008 great financial crisis, the events like 2001 dot-com bubble, these things shook that confidence and the trust. Today also, I mean, I think I'm from TCS. We had a recent news this week of like around 12,000 people getting laid off. What is it hitting? It is hitting the trust factor. But the fact is that it probably is not what is being projected by the media. The real thing which is behind is probably that people are being asked to reskill and upskill themselves according to the needs of the changing industry. It's like there is a proverb in Hindi, right? That paap se घृणा करो पापी से नहीं. So the concept applies here as well. So the person's job is not going anywhere. That particular job profile is kind of getting shut off. So people have said, okay, reskill yourself, upskill yourself. And when people are saying, no, I have done this for 20 years, I'm not going to do anything, then I think, yeah, doors are open for it. Please find something which maybe we are not capable, some other place might be. So that is where it's heading towards. But if someone is saying, okay, I have done this, I will learn this, I am ready to move forward, they are fine. And industry is changing with time. I mean, earlier the cycles of these industrial changes were more like 5 years, 10 years. Now I think every 2.5, 3 years, the industry is going to rapidly change. Things are shaping up. So today, machine learning, blockchain, and cloud are sitting right on top of it. We are actually currently doing a lot of deals there. Maybe in 3 years, we have quantum machine learning and quantum computing just sitting there behind the back. So it's coming. So I think that's where the students and faculty probably have to kind of, it's not about learning the technology, it's the openness to learning the technology and the things and understanding what is core and what is more changing, and adapting to both these things would be key, and learning and unlearning in the entire process. So, as I said, it's so the art is, so basically we are not actually measuring credit. So this is the crucial line. So this is the backbone, right? Credit is modeling the science and art of measuring risk and trust, which move both hand in hand. So when we feature engineer, as we shown in the equation, we are measuring the risk, and that's why we are bringing those percentage, interest rates keep on changing. Interest rate is an apparatus too, and inflation rates and all of those things. Yields, all of these. And trust is that element which is never seen but that is measured. So trust, risk. How much is the risk? How much can I trust? Now I think this is something of some of the interesting contents I have kept actually. Given that we are running short of time, probably I'll skip it, but this is there, you can always pick it up. And these are like how credit risk is basically broken, and I think I've tried to cover in a very simplified manner some of these aspects. So I covered like yeah. So basically the fact is that eventually, so this is what I was talking about, that the risks can be about these kind of risks where we have counterparty risk, credit risk, and that. So we have quantitative piece of looking at it, the qualitative part of it. Then we have parametric and non-parametric way of looking at it. And there are structural equations and then credit migrations which are happening. And this is how the entire broad level framework is. And these are some of the areas. So, and I will just quickly take a minute to cover one of the key concepts here in a very nutshell manner rather than very expansive way. And then we will probably jump into a bit of a programming just to bring everyone on the same page. So what do we build eventually, right? So there are three models, and there are a lot of other models, but these three are structural pillars of any credit risk model, which are known as these three. Heavily used jargons in the industry, right? One is PD. PD is nothing but probability of default. LGD is loss given default. And exposure at default. And the beauty, I don't know who coined these terms, but the beauty lies in the words actually. So everything is moving around default and bankruptcy. I think very, very negative words, but yeah, that's the nature of the business. So when a default is happening, trying to measure the probabilistic part of it, and there are multiple ways of measuring it. That's why all the techniques like GLMs, even machine learning and everything will fall into this to measure that probability. What is that? And it is basically, I can in simple words say it's the MLE or maximum likelihood estimation. That's what I'm. So basically, and then what is it? So let's break it down. Likelihood is the probability piece. Whenever there is a word likelihood, probability, there is a chance. So I'm constructing a function using chance. Then I'm maximizing that function and probably doing its double derivative as well. So first a del x and then del2 del x2 of that function and then trying to estimate it, and that is what probability of default in short is in mathematical words. Loss given default, very, very, I would say I'm in love with this word because it brings the Bayesian concept with it, right? Given, this is the keyword, it basically covers that what will be the loss if the default happens. So which is like P of A by B. It covers it itself, that's what is happening. So if the default event happens, how much loss I'm going to incur? And then I think there are aspects of it. So one of the examples I will take, how do these things translate? For example, probability default is a bimodal distribution. So default happening, default not happening. Or in simple words, one is good population, the other one is a bad population. Two different distributions. Generally it doesn't happen that way. In realistic world, it looks like more like this. So one is, so there is an overlap between good and bad. I can never easily distinguish that is the zone of where, and that's why your these metrics, what is it called? Confusion metrics come into picture. Any machine learning model, when it evaluates, it measures the confusion metrics true positives versus false positives and what is the true positives. So all the maths come from there. Now here the distribution of, for example, the good is like this and the bad is like this. This distance is basically at the maximum point, the distance between good and bad. And this is in a very jargon manner which you have learned or read a lot of this, KG or known good bad. Known good bad as in the bank knows that, why they are known? Because they are on the book of the bank. I know that particular, so if there is an HDFC bank and it has an XYZ customer, it knows, okay, this customer defaulted, this customer did not default, and that's why they constructed a distributional pattern and then they identified this. So a good model will be, so it's a non-parametric test. Why non-parametric? Because there is no specific structural equation behind it to measure it, but rather the idea is that when I plot the two distributions, Kolmog's group small number known in short KS distance. So this KS is maximized. That is the point where my models are doing best. And there are other parameters that we will cover in the next half. So there is a KS, there is an AUC, and there is I think these three are the backbone of measuring all of my credit risk models. So, and these are the measuring parameters. Whatever I build, I eventually go there, and so sometimes your AUCs will be used, sometimes your, so KS is non-parametric, it will definitely be there. Gini is basically an entropy-based function, it's a loss entropy-based function. So, lower the entropy, better the model kind of information loss. Yeah. And the third is basically, which I just trying to cover here, is exposure at default. Right? So, at the point of default, what is my exposure? Right? So that means that if I am a lot of how much impact it will have on me if the default happens. Me in the terms of bank giving the loan, how much it is exposed. So it will time to time we keep on measuring the. So I think there are. So PD can be sometimes called as counterfeiting credit risk, probability of default, likelihood of default. There are various terms, but the backdrop of it, and when these three, so there is something called loss reserving, LR. There are measures of measuring it short term and long term. Long run is known as long run average LRA, short term is there. Now, these three parameters are multiplied together. And the interesting piece is that loss reserving principle actually happens even in insurance as well. So they also call it reserving, but they slightly measure it in a different manner. So the words will change, but the mathematical framework of doing this calculation will remain the same. Generally, gain reserving is the same similar concept. Mathematically, I think they, because it's, so I'm just digressing to the insurance piece of it just for a second, just to measure. So, insurance business, the graphs are more like this, I mean, not even like this. They go into more of this. So when we are basically building normal distribution, so PD assumes that the distribution will be like this, like a normal distribution, but in reality it never happens. And that's why a lot of new algorithms come into picture to identify the right kind of a distribution to do. So distribution fitting is one of the key aspects of doing. So even before you fit the distribution, you have to understand and identify the data and do those things. So this is basically my close to, I think this is gamma. This is gamma distribution. So where I have like extreme one of it. So I think again, so distributions, understanding them. So it all starts from default median, which is the beginning part of it. So this is gamma. And there is, so why this is gamma? So let's assume there is a insurance firm. This is frequency, this is severity. So I have a particular claim which is extremely severe. What if this would have changed to this? This would have eaten the entire industry. If the gamma shifts is curved this side, so that means I have a high frequency event and a high severity. That is an extremely high occurrence that is happening. So this is representing entire insurance industry, the entire industry will sweep out. If this is happening at an individual insurance company, that will be swept out. So it never happens. Rather it happens in the gamma distribution mechanism, and when this is like high frequency and there are other variations of it is called zero inflated polynomial and other. This is sometimes measured as 3D distribution. This is not found in credit risk business. Similar stuff, but in insurance they measure it with a slightly different mechanism. And one of the other interesting things which I would like to cover before I jump is about loss given default. It's a very interesting. So probability default we have seen it's a bimodal distribution with like this. A loss given default would be more like I have, let's say the loss, the default event happens. It has happened now. Now how do I make the recovery? So so what is default rate? Or so what is the loss given LGD? LGD rate is measured as 1 minus recovery rate. It's a negative of it. So how much I recover? This is 100% minus recovery. I get the LGD rate. So when I am measuring, I don't measure LGD directly. I measure recovery rates, and then we'll find out from there. Now I'll take an interesting case of this one. Let's take something known. Vijay Mallya, everyone knows, right? So let's take Vijay Mallya's case. The leaker trial. And I will add some hypothesis pieces as well. I'm not supposed to bring out every detail, every murky detail, just trying to make the session interesting. So Vijay Mallya's, so he's the baron and I think the Unicity is something which is. So now let's not exactly put Vijay Mallya on the pedestal, but rather what we will do is we take similar to Vijay Mallya, there is a legal industry which went bankrupt. It has been taken from bank, let's say some 100 CR, or let's make it some whole unreasonable number, 1000 CR, right? For a certain period of time. Now that bankruptcy has happened. Now the bank officials are like sitting down there is, and what are the reasons behind it? So there is a change in management that happens. That XYZ talent was there. This is that Vijay Mallya is he gave his son this thing that okay, you run the show, and he was incapable. Obviously the capacity that piece comes into picture. So weak management is one of the reasons why. And I think one of the papers here, like when we had discussed, this actually contains the thesis. So when loss given default models are failed, so weak management is one of the reasons, and all of the other factors like my management change. So rapid management changes are happening, liquidity is getting constrained, and all of these things come into picture. But while measuring LGD, it is very important to be very factful that what are post-factory events. Some of the events, so let's say I am measuring LGD, but I am measuring a PD model's parameter, then I am going to the same problems of all of this conditional effects, and this can happen, and that can screw my models completely. So now this is what happens. So the bank is looking for the recovery, and it has a detailed discussion with the board of members of XYZ along with his son, Lokesh Yu and MD Mr. M is there, and they have a discussion, okay, how do we make the recovery? And I will set up the mathematical framework from here. So it's like, so he said, okay, I have liquid cash available of, let's say, 50K, 50,000 crores. And then he says that beyond that, I have some inventories, unused inventories of around 10K is there. Then I can create some future products out of it and sell it in the market. So basically banks branding in, so that's why the banks also have marketing professionals alongside this. So they now help the branding of defaulted brewery companies, defaulted mechanics, they will come and they will try to say, okay, let's do the business together, get these things sold in the market. So let's sell these breweries. And then eventually when all of this is done, now there are portions. So this is the positive part of it. Now you have, now the ugly part comes into picture. You have management and staff working. You have to pay for their salaries as well, right? Which is the negative cash flow. So all of this is positive cash flow. There is a negative cash flow as well, which will get subtracted from all of these recoveries, which is already happening month on month. And the principle of TBM comes into picture. Time value of money, which is covered in the beginning. Because this 50K and this 10K and let's say this 5K is not equivalent to 5K here. This 5K here is not equivalent to 5K here. This is more riskier. I am still projecting it that this will happen. So I will discount it. So there is a concept called discounted cash flow. This is from accounting actually. Anyone from accounting background, they will know what is discounted cash flow. Balance sheet editor. But this is applicable. So even in the space of machine learning, you have to bring all of this into equation. Then you can actually bring all of your features and stuff like that to be working in together. So this happens. Eventually, everything gets settled. There is another big recovery happens here, which is close to let's say 35 KCR. And this is basically they will sell up all the equipment, everything, and get rid of it completely. Or even the bank may choose to. I can further run the operation until if it is something, it's a brewery, they want to close it. If it's something like which is useful for public and they don't want to shut it down, the bank will take up. They will further appoint a board member and they will run the show even in the future, and it will never be closed. And I think one of the examples from 2008. Great Recession was AIG. While Lehman was chosen to be a scapegoat, whereas AIG was saved because people's money was stuck in AIG. If they would have chosen AIG, the entire system would have crashed and people would have gone to, like, I have my entire life savings is gone. What do? I have nothing left but to do the unthinkable. So, to sustain those kind of businesses, banks, governments, they take initiatives to save it. So this is how, now the fun part is if I look at from a mathematical angle, sorry for a messy board, but if you look here, this is probably not a very nice looking distribution. When we model here, linear regression, logistic regressions as well, we are using unimodal or single modal regression distributions. This is a multimodal regression. This is even a bimodal. There is a recovery period here, there is a heavy recovery period here, and then there is a smaller recovery period. So this is not exactly something. So the biggest game in the entire, or even in data science industry, identifying the right distribution and what kind of assumptions can work around, and then kind of, and even if you build the model, good for academic curiosity piece, but can it solve the problem? Can you communicate the same message to stakeholders? Can you bring them on the same page? Because at the end of the day, the business decisions have to be taken based on that. The model is not taking the business decision. The model is making the road for a quantitative way to set it up and taking all the assumptions which management and that particular bank or entity has taken into consideration. So here is in simple words, this is basically a beta regression model. This is exactly. So if 12th class mathematics or physics, somebody remember, there was a beta decay problem in tin. Madame Curie used to do some experiments. The tin, there was a radioactive decay. So this beta regression is exactly the same regression model or the same distribution fitting model, which uses recovery pattern in a loss given default. So behind the words there is, so doing the programming piece, you can choose today machine learning, tomorrow you can choose something else, and tomorrow. But this is the story behind it. How it happens, why it happens. So now, okay, so this is actually a very interesting pic I have just kept. So the idea was this, there are two guys right here, three guys actually. This guy here, this guy here, and this guy here. Right? If you think about risk, the three people have different viewpoints about risk. Objective reality, which I exactly talked behind, the backbone behind tensor mathematics, that what is true for him, he might be thinking, oh, this guy is going to break his bones. This guy, okay, this is my day-to-day job. The other guy, I don't care. So they have, all three have a different viewpoint. But right now, this guy is looping around into this music, is getting this thing and taking that risk. I think that is the fact. And everyone, probably audience might be thinking from different. Now, this is the one of the most interesting pieces. So this is, let's say you build the model. Building a model can take easily 2 to 3 years sometimes. Data collection, business strategy building, you would have multiple discussions, and it's a very, very costly event because it's not just programmers. The people who build, like the kind of department I run, which is basically a department of modelers. So data scientists what actually came in last decade. Modelers has existed for last 30 years probably. So these guys are multi-dimensional guys. They have business capability. They can even probably having understanding about law as well, accounting as well, finance as well, economics as well, and coding into multiple languages, because banks doesn't just do, let's do some Java programming, let's do some C#. No, they can be running into multiple. Somewhere it would be an Oracle framework, somewhere it would be Python, somewhere it would be PySpark, somewhere it would be something else, and tomorrow something else would be there. Now, so models, let's say you build it, and tomorrow you need calibration as well. Or so regulators will come and ask you this question, or ask the bank CEO or the board of directors, regulators, how do you ensure that you build a model, it's always going consistently? So that is the principle of model monitoring. And you build any kind of model, be it statistical machine learning, you have to do model monitoring. So this framework is not again going to change. This is going to stay there. Not only today, this is going to be there for next 5 decades as well. And this is there even 3 decades back as well. When the banking systems in America or others, and even India. So India, I think we still haven't formalized all of this, but I think there is a great opportunity. The way we are expanding, the way we are growing, I think next 5 years this is going to be very relevant in Indian banks as well. So this is probably, I would say, the current material which is used in US, but this is going to be relevant in India. In fact, I think there is a tremendous opportunity space in India. We do not have the right data in place, but that is, every failure is a stepping stone for a success, right? So this is the future opportunity space which we can find. So how does the entire model development ecosystem? So individual modeling is fine, but how the entire ecosystem looks like. So this is how the entire piece looks like. That we do the strategy piece of it, the reporting piece of it, the acquisition. So basically, when we are trying to acquire new assets, and so model monitoring can be used. Model retain. So basically, whatever distribution measurement in this, all of this is done probably every month or every quarter to see, because you cannot build models every time. Model building is a very, very costly exercise. You have to fetch out data from multiple sources. You have to move the entire bank almost, and then and modelers are very costly. They are one of the most costliest software programmers. Probably they are even costlier than data scientists at some point, because
banks, senior VPs, executive VPs can also be modelers. So, and they will make decisions based upon that. So, bank cannot do the model development all the time. So, they will be running this kind of framework as well. And even in our department as well, we have like, let's say we have a team of 50. Then we have practically 6 modelers or 7 modelers, very senior ranking guys, who are hands-on probably most of their work, explain things, do multiple type of stuff. But then we have a major department which is running into the model monitoring, quality, governance, administration and everything. So that is how the entire show is run. Now this is how the framework actually looks like in a real bank. When you have data sources, this is your data preparation part, or what is known in machine learning world feature engineering piece. Then you really here develop the model or the algorithm piece of it. So these two are the most important piece of it. Then you finally deploy these models, keep doing, and these layers are interconnected to again. So because whatever you are developing in for model development, that same framework has to be replicated of the data preparation, even the if then else logics, or if you're creating any defs in basically any def functions in your Python programs, all of them has to be replicated on validation, and not only just replicated in terms of code, but in terms of data as well. There has to be a word-to-word similarity, and wherever there is a drift, I think we will measure that as well, that how the drift is happening. So we will look into the modeling data, and then we have development, and then the deployment piece, because you develop it until unless you deploy it, how would you ensure that it's working? And eventually this is the layer of which we talked earlier, MRMG, Model Risk Management Group, or the Model Governance Group. We are building it even before it go to the regulators and business stakeholders. MRMG, so regulators, so business stakeholders might work hand in hand with the development group, but Model Governance Group will keep a hawk eye on what kind of, and they are extremely vigilante. They're in one of the Dilbert books I've seen actually that they are like that I am the Batman of the model development team. I will keep a hawk eye on whatever you are doing. So that's how the model governance piece works. Now this is the entire process flow of the model monitoring process. So here we initiate, so the business starts from there, that the definition of the monitoring metrics are done, and then the data preparation is so here the data preparation is done, and we kind of look into each of these. So data collection and data processing, data cleaning, data is put into place. So okay, we have put the data in place. Then the next part is that we do the performance evaluation of it. Right. So performance evaluation we draw. So basic, again the basic would be draw that confusion matrix. What is my rate of true positives versus my false positives, and entire ecosystem of metrics will be built out. But that is the foundational stuff. And then we identify, okay, so we have set up the matrix. Now, what are the root causes of the deviations or the changes, and how do we remediate those things will be into the root cause and remediation piece. And eventually we have done every part of it, documenting it becomes extremely heavy. Regulators are extremely keen on every piece of documentation ever written in instance. And that's where a lot of banks actually go for a toss. So this is a key part. Actually, this is where I think the generative AI piece will disrupt. So in this piece, and probably the development. So when you are doing coding, right, on multi-dimensional coding, there are modelers, 5 modelers probably in the bank who can code into multiple languages, but your rest of the talent pool might not be able to. So for them, provide them GitHub Copilot. So I think training the future batches, even in the college today, right, or any of the academic setup, training on some of these tools will help them leverage that in the industry. Right? GitHub Copilot, right, these kinds of tools. Then I think the other piece what I'm talking where generative AI or tools have an application is probably into the documentation and reporting, because this is a very grinding work but extremely crucial. So if, and one of the biggest or one of the most interesting problems or management problem is that how do I engage the time and effort of my analysts? So are they going to spend their time on insight generating, or they are going to put their time on the paperwork? Basically, documentation is more like a paperwork. So generative AI can help in, or the deep learning phenomena can help in basically automating all of these things. But someone has to learn about it, and I think that is where the learning mechanism. So not all generative AI is used in the model development because it was all heavily regulated there. I think this year, federal body has, not this year, I think 2024, they have passed out a federal rule, and I think Indian bodies, specifically the RBI and all, I think it's work in progress in there, where they are going to pass machine learning and AI models into the space of regulatory model development. So it's work in progress in India. In US it has passed last year. I believe probably as we have more better data in Indian context, I think, and GenAI is not a rocket science. Okay, I draw the static band and data. The data has to be in place, and if there is a data which is in a bad shape, so it's basically the concept of ego, right? You have garbage in, you have garbage out. So if you have bad data, it's going to be multiplied multiple times of that. So the first piece, and I think most of the banks today, including some of the Indian banks as well, are working on sorting the data strategy first. That is the secret piece here, which is not even, so a lot of people will talk about a lot of jargon stuff, but that is where the actual effort is going on. Then put up some of the metrics together, all in comparison to one space. Now it's so this is, we have talked a lot. So this is how exactly the distribution looks like. So this is for the academic purpose they have drawn into that, but in reality the distribution looks like this. So my good just goes below, bad is going there. I'm trying to measure the difference at the point there, and so this will be like covering like this. This will be another distribution. They have a minuscule distance between them, and that is that arrow marking here. That is my T. That is my KSP. And this is my continuity matrix. How the AUC curve is calculated. This is the backbone of it. And this is the exact table basically how the KS is calculated. So basically, I bucketize the information. So we bucketize the information into multiple buckets. Can I get another? So so here like so there are multiple buckets that will be created, and then the peak point where the maximum distance is happening, that distance is greater than that becomes my case. Gini is basically so it is measured from AUC itself. So this is how the curve is created. So it basically so if there is a 45-degree flat line that gets created from tangential ASP. This is basically equivalent to having no model at all, and decision making at a randomness. So this is equivalent to I am tossing a coin and I want to see if it's a head or tail. So this is like that. And on top of it, when you put this curve up, that is basically when I have built the model. So basically, what is the gain I am getting off it, and AUC, Gini, and KS, these are the parameters based on which the benefits are measured. This is basically an important area which looks into if I have to measure. Thank you, ma'am. No worries. So how much time I have left? How much time I'm left? How much time?
Your session time was
over. cover these concepts. So there is a population stability index and characteristics. So basically the idea is that if I am, and I am looking from a model, so this can work basically, so this is again a non-parametric distribution. So this can not only apply for model monitoring, this can apply for new development as well. So let's say I have built a model 5 years back, things are working, not working. Even before I start building a new model, what I will do, I will bring the new model features in and try to see if the population is going unstable. I mean, whether it is still equal and if there is some kind of a drift happening into that or not. So this is basically breaking down into just like this multiple groups and then looking the difference percentage actual minus percentage expected into log of percentage actual by percentage expected. So and there is some interesting concept which I currently have missed. This is something very, very interesting. This happens inside the feature engineering part of it, which is basically called binning, which is one of the most crucial concepts because what we are using, so if you have numeric data, world is easy, but that is not the way the world works. So a lot of data comes into category format, right? Now from category format, numeric data, it's pretty easy. I mean, you want to make the similarity of it, just measure correlation. But in category data, how would you measure it? Then comes something like this. This is called chi-square distribution, non-parametric distribution to measuring. So this is, and the framework is something like this. I might not be writing the exact formula, but this is O minus E square by E square. So this is observed minus expected square by expected square. Square is basically to, if there are some negative differences, to make it in a positive absolute value. Basically, this kind of a thing happens. That's why it is square. But the idea is obvious. Because if you look from an ordering point of view, this is also square, this is square. So ultimately it comes from the same thing. And if you see, that is again the idea behind objective reality. We want to bring the things onto the same plane. How do we measure things? So mathematics is not to make something complicated. If you read it more like a philosophy, you will understand the logics of the things. I mean, so Isaac Newton first developed this mathematics, and then later on Albert Einstein used for general theory and special theory of relativity. And today, even a lot of industries, be it in credit risk or some other data science field, they are using the similar maths. But the mathematical background comes from the times of Isaac Newton. Now, okay, we do not have the slides, but it's fine. Okay. So binning I was talking about, right? So binning is, for example, so there is a middle part of it which is character stabilization, CSI it is called. CSI is basically at an individual feature level whether the variables are similar or not. But then to measure this, like, so normal numeric it would have been very easy. But if it's category, then how do we actually identify? So this actual versus predicted concept is going to go very long. That is the entire frame of it. So let's say we have some variable for example, coming to office on time, let's say is the y. And one of the x variable, and I'm just taking one for the timing just to showcase how binning works, is basically whether what kind of mode I came to office today. Is it bus? Is it car? Is it two-wheeler? Is it bike auto or whatever different format I use? So then I can create multiple buckets out of it. How many number of distributional patterns are there? So once the buckets are created, then I am trying to look the difference between the actual and predicted and try to create here a concept dropping the background, but the idea behind that is basically so it's basically captures the information value, right? That is the main intent of it. So it looks into the information value of the property and then the maximum information. So it's basically called data evidence. Sorry, I forgot the name. So it's in short known as WOE. So the evidence piece is basically information. So it tries to maximize the information. So that is the feature engineering principle. That is what is being done for each variable. And what it does, basically I have this, I have like one, this, and this, right? So my curve, so it follows some of the principles like monotonicity of the graph should be there, because when I am measuring the linearity in the system, so that is the crucial piece. Why do we do not use a lot of machine learning as of today? Why do regulators are against it? So the reason is that, for example, and I'll take a simplified example, someone, let's say, so when a credit bureau or a loan is rejected, right, or so the bank has to give 5 rejection reason codes, that's what. Now, if you are building a machine, let's take you are building something with one of the machine learning principles, right? So, what is one of the good ones? Can someone name some machine learning principles? This is tool.
Which type of? Which types of machine learning? Supervised or supervised?
Supervised?
Decision tree, linear regression, SVM, KNN.
So let's say we take example of SVM. Right? Now SVM more or less looks from a plane perspective. It doesn't look from a, so it's basically the separation of the events and so it's basically a plane which is intersected, and what happens, it can be curvilinear space as well. Now SVM we applied here for a linear regression principle, like I'm giving load to someone and rejecting it, and it is traced out by a plane. What happens? Here the load rejection happens, and here also the load rejection. So first breakpoint is here. So here, so the load rejection is happening here exactly, this point and this point. But I'm denying someone here credit, but here it is going up top as well. So I'm saying you are rejected, but someone else. So it basically brings in bias into picture, and that is where regulators are averse about using machine. So there are work going on in terms of making constraintized SVM, constraintized even neural network, and all of those things are work in progress. But when you put constraint on top of it, for example, in a neural network, which is again a deep learning framework, a function of generative AI or AI nowadays, what happens? You are actually making it logistic regression. So if I can make a traditional logistic regression or at max a gradient boosting model, why would I invest so much energy? So that debate is the cause why machine learning is still delayed into some of the more highly regulated fields, like into claims and insurance, healthcare, and into credit finance decisions. So these areas, still there is a massive debate, not only in India but across the globe. This debate is continuing. Probably sometime in the future we will find out the a neat way of doing things, but without these kind of challenges. And then there are some of these other concepts that they are point to double the odds, going over the strategy and this. So point to double the odds is basically it is basically again what is it's a function of basically, so it comes into this logging mechanism. So it's basically failure to success. What what is the chance? So basically, India and Pakistan go for a series. What is the chance of or probability of India winning the entire series? It's basically a similar type of question, which is being answered by point to double the odds. And I think this is where I think we are probably most of the last two slides. So this actually covered in the beginning in a more simplified manner. So here I have kept some material as well. You can, if time is not complete, but I think we can do the presentation. So what are the modern day challenges? I mean, where do we stand right now, and what is the challenge of the future? So this is what is right now happening. So there are technology shifts which are happening consistently. So to 5 or 10 years, and I think today also there are a good set of banks which kind of probably do the creditors modeling on Excel and PowerPoint and Word document. Very, very traditionally rudimentary. So it basically depends on the size of the bank as well, how much technology capability they have got, if they are ready to. So banks' core business is to lend money. Technology is something to aid it, but whether technology is eating into their core business or not, that is like the fundamental principle why certain kind of like technology they are using. So some banks probably are using SAS, statistical analysis software. More advanced banks are using COTS, basically commercial off-the-shelf software, which is basically utilizing open source tools like Python, Java, etc. And Hadoop, AWS Cloud, these kind of functionalities to basically do the same work. So principles remain same, what I have covered in the slides, but the way of doing it changes across. Some use SAS, so it is basically ability or staying tuned, and no one method is bad. So for example, Microsoft still is powerful. What is the disadvantage? Microsoft charges a particular fee. If your size of the bank grows and they charge you individual licenses, it's going to procure it again. SAS charges extremely heavy. Whereas if you're doing it on Python or PySpark or some of the open source tools, you are probably investing heavily today to build your own ecosystem of these things. But tomorrow you don't have to pay it, you just have to maintain it, and all the control is lying with you. So there is a regulatory pressure, there is a pressure from the market, and on one side bank is there and it has to continuously think, shift, they have to increase scale and all of those things. How do they become profitable? When there are movements happen, the technology shifts happen. A lot of people, for example, and I have seen this, I have seen 5 technology changes in my entire career till now. So, and I have shifted from one tech to another tech, just seamlessly, but a lot of my colleagues have not. So what happens is that, let's say I'm working on SAS. I've worked on it for 10 years. I'm saying, okay, I don't want to change my tech, but the bank is saying that we are moving. So there is a conflict between the management and the employee. Eventually, employee goes out, a new employee comes in. But where is the loss? The loss point is that the new employee has to know what's happening in the background in the bank, which is never documented. And that's where the major roadblock in the banks today is. There's a documentation. What is happening, why it is happening, and how it is happening is not captured. Those messy organizational changes, the changing shifts, the changing priorities not captured. So much bigger than data science problem, I would say. I mean, data science is important, but this is what drives the bank, this is what drives the businesses, and if we layer by layer peel out things, we will actually see all of these. So the role of data science, and data science actually obviously plays crucial role. We all discussed here like how the mathematics and the programming. So programming is the final implementation of it. It's the language in which I want to put it on. But then eventually how and what is the data science. I have some interesting slides. Paucity of time is like stopping me so that actually I was sitting with my 7 years old to kind of do an experiment. Can I explain him what I do for a bank? And what I told him as a story, he actually commanded the ChatGPT to create a picture for it, and he actually crafted out the slides. I will show it in a glimpse. So yeah. If I'm permitted, I'll just show that. So that was just a fun thing. So this is what I think my son created. So this is like the way he thinks bank is, and he kind of created a magical world of bank houses. This is his fairy tale stuff. And this is what is happening. So this is the broken system. So if I think someone asked me this separately, that if everything is recorded, why it is not measured? Because if it's on the books, handwritten book, it will stay in the book. How do we digitize it? I think generative AI now, today, how to get into this text and convert it into some modernization, data modernization right now is happening. That is the event, and I think most of us should target AI and GenAI in this format. That is where the banks and all the industries are actually shaping up. So this is something crucial. This is made by my son, right? This is not made by me. This is how he defines me. That my dad looks like this. He holds a laptop and keeps on scrutinizing the data, the stats, and this and that. And it looks like a leap. This is how he thinks that the customers are profiling, basically. Said profiling and segmentation of customers. Various, this is the wishing well that I drop a point the customer looks like that. This is like the dangers that the bank is faced off. These are the team of data scientists working together. They are trying to deal with the monster called fraud, or how to bring it right. And this is how the risk strategy. So basically, you think of the crystal ball is more like an SDM or a risk. That's the hedgy part of the risky piece. That is the big part of it. And eventually, that is the idea. Basically, the data scientists are trying to convert everything into, and like every 7-year-old, they have a moral of the story, right? So this is the moral of the story, that this is the bank does to measure the risk and so forth and so. Eventually, he wants his dad to have a good sleep and be with him and tell the story. So I think I'm done. So thanks for your patience. I know I was very fast. Thank you.
In conclusion to this session, provided a foundational overview of the convergence between data science, credit risk management, and banking technology. Without delving into the technical intricacies of programming, we aim to offer a conceptual introduction to how data-driven methodology are increasing integral to modern banking practices. The discussion emphasized the role of credit risk modeling, a critical branch of data science, in enabling financial institutions to make informed lending decisions. We explored how banks utilize data to identify borrower characteristics, assess financial health, and develop predictive models that help mitigate default risk while optimizing lending portfolios. A key takeaway was what cannot be measured cannot be improved, highlighting the importance of measurable data in enhancing decision making and risk evaluation. Real-life case studies and simplified visual aids were incorporated to illustrate practical application and encourage broader understanding.